This question is from GATE Mechanical Engineering of 2012. This is question number 52. Question number 52 and 53 has linked statement. So the statement is air enters an adiabatic nozzle at 300 kilopascal and 500 Kelvin with a velocity of 10 meter per second. It leaves the nozzle at 100 kilopascal with a velocity of 180 meter per second. The inlet area is 80 centimeter square. The specific heat of air, that is Cp, is 1008 joule per kilogram Kelvin. Now question number 52 reads, the exit temperature of the air is, so we need to find the exit temperature of the air from the nozzle. Okay, so using the first law of thermodynamics, the steady flow energy equation, let's write steady flow energy equation, we can write this as H1 enthalpy at inlet plus V1 square by 2, the kinetic energy at inlet, plus per unit mass, of course we are writing the heat supplied is equal to H2 at the exit. Subscript 1 and 2 represent inlet and exit condition respectively. H2 plus V2 square upon 2 plus the work done. Okay, we are writing per unit mass, please remember that. Now the inlet and exit conditions are given, right? So in inlet condition, at inlet we have the pressure P1 is equal to 300 kilopascal, temperature is 500 Kelvin, and the velocity at inlet is 10 meter per second. Okay, also the inlet area is given A1, which is 80 centimeter square. Okay, and at exit of nozzle, pressure is 100 kilopascal and velocity is 180 meter per second. Okay, so from here we can guess that it is a converging nozzle. Okay, also the heat capacity Cp is equal to 1008 joule per kilogram Kelvin. This is specific heat capacity at constant pressure. Now since it is an adiabatic process, so Q will be equal to 0. Okay, also the work done in this process is 0. So we are left with this steady flow energy equation. It will become H1 minus H2 is equal to V2 square minus V1 square upon 2. Okay, and enthalpy we can also write as Cp T1 minus T2 is equal to V2 square minus V1 square upon 2. Okay, now let's just substitute the values and get the result. So Cp given is 1008, T1 is 500, T2 we need to find out, exit velocity is 180 and inlet velocity is 10. Okay, divided by 2. So after calculation we'll get T2, or 500 minus T2 will get 16.02. So after calculation T2 will be equal to 483.97 Kelvin. Okay, so among the given options, option C is the correct choice. For more information on this topic, you can refer to NPTEL course lecture number 17, nozzle flow, isentropic relations, area velocity relation, choked mass flow rate on aircraft propulsion by Professor Vinayak and Kulkarni of the Department of Mechanical Engineering at IIT Guwahati.